the moment of force by a couple. Okay, and in this case the R, this R will be defined, or you can define this R in the couple moment in the case of difference. Okay, so this R can be said as the difference between two moment arms. Okay, so it can be a difference between two moment arms, and F is the force, and we are expecting that the F is equal. Okay, or the only difference is the direction. Okay, so this is how we assume the value of F. What is going on the WhatsApp group? I think you need to pay attention to the lecture rather than your futile matters which you can settle later on. Yes, Arizi, what's the problem?
अस्सलाम वालेकुम सर। सर मेरा क्वेश्चन ये है कि आवाज नहीं आ रही। हेलो, एनीवन कैन हियर?
Yes, I can hear you. Go
सर
ahead
ये
with
जो
your question.
ये सर जो आर आप बता रहे हैं कि ये डिफरेंस बता रहे हैं, तो ये किस तरीके से बता रहे हैं? पोजीशन वेक्टर लिखा हुआ है, क्योंकि ये तो कि आर पोजीशन वेक्टर है, तो ये डिफरेंस बताएगा।
Difference of two arms.
सर मतलब ये
As you can see in the diagram on the right, on the left rather, you see this is the point from where you are calculating this distance RA. This distance is RA and this distance is called RB. Okay, the difference between the two will make the difference, will give you the moment created by couple. So the couple will be the force produced by the force equal in magnitude but opposite in direction. This is what we know called couple. But when it produces a moment, so we can calculate the moment produced by the couple, not by one force but by two forces. Okay, so definitely couple is produced by two forces, so it means that the two forces will have some sort of moment arm. Okay, so the difference between the moment arm of those two forces will produce the resultant moment arm in that object. Okay, so this is why R is the difference in position vectors of the two moment arms. The two moment arms are called the position vectors. Okay, now scalar formulation. The moment of a couple M, figure 2.7, defining as having the magnitude of M is equals FD. F is the force and D is the perpendicular direction between the two forces. Okay, F is the magnitude of one of the force and D is the perpendicular distance or moment arm between the forces. The direction and the sense of couple movement are determined by the right hand rule, where the thumb indicates the direction, where the fingers are curled with the sense of rotation caused by the couple forces. In all cases, M will act perpendicular to the plane acting these forces, containing these forces. Okay, M will be perpendicular. So it is same as the linear momentum which we discussed earlier. You have the same use of right hand rule, okay, as you did earlier. So the only difference you have here that now D defines the perpendicular distance between two forces. Okay, so rest of the assertion about momentum is same as we discussed earlier in the linear momentum. Vector formulation. The moment of a couple can also be expressed by the vector cross product using the previous equation like R cross F. Application of this equation is easily remembered if one think of taking the moment of both forces about the point lying on the line of action for the force. Example, the moment are taken about A in figure 4.26, the moment of minus F is 0 about this point, and the moment of F is defined in equation 4.15, this one. Therefore, the information R is crossed with the force F to which it is directed. Okay. Now, you check this out that looking at this diagram 4.27, movement is produced in the direction of thumb. Fingers are representing the direction of rotation, okay, and the application of forces. So the only difference you have now is that now you say that you have another force acting on the same direction, although they appears to be opposite, but both the forces are trying to turn the object about the point in same direction, that is same sense. Same sense means either clockwise or anti-clockwise. Okay. In the case of rotation, the direction is assumed as clockwise or counterclockwise. So you can see that whenever couple is there, whether you are just taking couple or calculating the moment of a couple, the forces acting will always be in same direction. Okay. Now there is a confusion that whether in this diagram the forces direction are opposite or same. Now we will determine the direction of force with reference to the point of rotation. Okay. So with the reference of point of rotation, whether the object turns in clockwise or it turns in counterclockwise. So then we determine what is the direction of the force. This is how we indicate the direction of force. So it is not just the direction that going towards the origin or away from origin, because here you are not assuming a linear motion, but you are assuming a circular motion or a rotatory motion. So in that case, you have to take a reference point about which the whole system moves, okay, and then you can take it as the direction positive or negative. Okay, this is how it works. So it is not a contradiction, it is just a matter of understanding. So these two forces are negative with reference to linear motion, but they will produce the rotational motion in the object. Okay, so with reference to rotational motion, we will determine their direction to be positive or negative, whether it's positive or it's negative. Okay, so this is how it works. Now look at this example, which the clear the concept of coupled movement. Determine the magnitude and direction of a coupled momentum acting on the gear. Okay, this is the common shape of a gear which is found in different um, mechanical machines, and that mechanical machine moves from uh, heavy oil tankers, ranges from heavy oil tankers up to your watches, your wrist watches. Okay, the wrist watches in your hands do keep such type of gears. So it's a very useful or a very basic type of machine which is used in different types of machines and mechanical systems to produce or to direct the force in different directions. Okay. Now what we have situation over here. Look at the diagram A, for example. 600 Newton forces are applied on the cog. These are called cog wheels. Okay. The plain wheels are where there are no such types of grooves. created at the end of the wheel. So mostly